Now we will discuss variation in acceleration due to gravity small g with altitude. Let capital M be the mass of Earth, capital R is a radius of Earth, small g is acceleration due to gravity at surface of the Earth, small m is mass of the body on surface of Earth. Now acceleration due to gravity on Earth's surface is given by small g is equal to capital Gm divided by r square. This relation we have derived in earlier topic. This is equation number 1. Here capital R is distance of the object which is on surface of Earth from the center of Earth, that is equal to radius of Earth. Now when the body is taken to height h above the Earth's surface, as shown as in figure, then acceleration due to gravity will changes to gh, and this gh is equal to capital Gm divided by r plus h square. This is equation number 2. Since here the distance of object at height h from the center of Earth will become r plus h. Now divide equation 2 by equation 1. We get gh upon g is equal to capital Gm divided by r plus h square divided by Gm upon r square. Here capital Gm will get cancelled. This equation will become gh upon g is equal to r square upon r plus h square. Simplifying, gh is equal to gr square divided by r plus h square. We can write is taking the r square here common, we can write gh is equal to gr square upon r square into bracket 1 plus h upon r bracket square. Here r square will get cancelled. Therefore equation becomes gh is equal to g into bracket 1 plus h upon r bracket raised to minus 2. In this term, denominator term 1 plus h upon r bracket square will go to numerator, the power will become minus 2. Now for the small altitude h, that is for h upon r is very less than 1, and by binomial expansion, by neglecting higher powers of terms of h upon r, we get the equation gh is equal to g into bracket 1 minus twice h upon r. This is equation number 3. This equation gives the acceleration due to gravity at altitude h from the surface of Earth. This equation shows that acceleration due to gravity small g decreases with increase in altitude. Now we'll discuss about variation in small g with respect to depth below the surface of Earth. Let capital M is mass of Earth, capital R is radius of Earth, then the acceleration due to gravity on surface of Earth is given by equation small g is equal to capital Gm divided by r square. This is equation 1. Assuming that density of Earth is uniform, it is given by density rho is equal to mass upon volume. But as the Earth is spherical, therefore volume of the Earth is given by 4 by 3 pi r cube. Now capital M, that is the mass of Earth, is equal to volume into density. Therefore capital M can be written as capital M is equal to 4 by 3 pi r cube rho. Substituting this value in equation 1, we get small g is equal to capital G into 4 by 3 pi r cube rho divided by r square. Here r square from denominator and here r square from numerator will get cancelled out. This equation becomes G is equal to 4 by 3 pi r rho into G. This is equation number 2. Consider a body at point P at a depth d below the surface of earth as shown as in the diagram. Means here at a point P below the surface of earth at a depth d. Therefore, distance of the body at point P from center of earth will becomes r minus d, that is OP is equal to r minus d. Now, if we imagine this imaginary sphere, inner sphere, whose radius is equal to r minus d, then m dash is the mass of this inner sphere of the earth whose radius is r minus d. The net force on the body P, the net force on point P or body which is at point P is only due to this inner sphere. As in the diagram, your body at point P below the depth d from earth surface, then force acting on the body at point P will only due to inner sphere of the earth whose radius is r minus d. Acceleration due to gravity because of this sphere is given by relation Gd is equal to Gm dash upon r minus d square. This is equation number 3, where m dash is equal to volume of inner sphere multiplied by density of the earth, as the density of earth is uniform. Therefore, m dash will become 4 by 3 pi r minus d cube into rho. Substituting this value of m dash in equation number 3, equation 3 will becomes Gd is equal to 4 by 3 pi into r minus d cube rho divided by r minus d square. R minus d square from denominator and numerator will get cancelled out. This equation becomes Gd is equal to 4 by 3 pi r minus d rho g. Equation number 4. Dividing equation 4 by equation 2, we get Gd upon G is equal to r minus d upon r. Therefore, Gd is equal to, or Gd upon G is equal to 1 minus d upon r. This becomes Gd is equal to G into bracket 1 minus d upon r, equation number 5. This equation gives the acceleration due to gravity at the depth d below the surface of earth. This equation shows that acceleration due to gravity Gd below the surface of earth at a depth d decreases with increase in depth. Special case, at the center of the earth, that is the depth below the surface of earth, d is equal to r. Therefore, acceleration due to gravity Gd will become 0. This shows that weight of the body of mass m dash at the center is 0 due to absence of force of gravity. Graph showing the variation of acceleration due to gravity g with respect to altitude and depth. The value of acceleration due to gravity g is maximum at surface of the earth, and it decreases with increasing depth below the surface of earth and increase in height above the earth's surface. Here the graph showing the variation of g with respect to altitude and depth below the surface of earth. Acceleration due to gravity is maximum at surface of earth, that is at a distance capital R from center of earth. It decreases inside the earth's surface as the depth increases, and also it or value of the g decreases with respect to altitude above the or outside of the earth. This is the graph of small g as function of small r, that is distance from the center of earth. We consider first for small r is less than capital R, that is inside of the earth. Formula for GD is formula for acceleration due to gravity is GD is equal to G into bracket 1 minus D upon R, or GD is equal to G into bracket R minus D upon R. If we'll substitute R minus D is equal to small r, that is the distance from center of earth, this equation becomes G of R is equal to G of small r upon capital R. This implies that G of R is directly proportional to small r, and this shows that the graph is straight line passing through origin and having the slope G upon capital R. Second, for small r is greater than capital R, that is for outside of the earth. Equation for acceleration due to gravity is gh is equal to g into bracket r square upon r plus h square. If small r is equal to capital R plus h, then equation becomes g of r is equal to g of capital R square upon small r square. This implies that g of r is inversely proportional to r square, which is represented in graph.